Good day and hi, my name is Sow Qing Xiang. Today I will have a task to develop a simple instrumentation system that able to detect presence of human through NodeMCU. DAQ, also known as data acquisition, is a sampling of the real world to generate data that can be manipulated by a computer. Sometimes abbreviated DAQ data acquisition typically involves acquisition of signals and waveforms and processing the signals to obtain desired information. The components of data acquisition systems include appropriate sensors that can convert any measurement parameter to an electrical signal which is acquired by data acquisition hardware. Data acquisition system can be classified into the following two types, which is analog and digital data acquisition systems. The data acquisition system, which can be operated with analog signals, are known as analog data acquisition systems. Following are the blocks of analog data acquisition system. Transducer, it converts physical quantities into electrical signals. Signal conditioner, it performs the functions like amplification and selection of desired portion of a signal. Display device, it displays the input signal for monitoring purpose. Graphic recording instruments, they can be used to make the record of input data permanently. Magnetic tape instrumentation, it is used to acquiring, storing, and reproducing of input data. The data acquisition system, which can be operated with digital signal, are known as digital data acquisition system. Following are the blocks of digital data acquisition system. Transducer, it converts physical quantities into electrical signal. Signal conditioner, it performs the functions like amplification and selection of desired portion of the signal. Multiplexer connects one of the multiply inputs to output, so it acts as a parallel to serial converter. Analog to digital converter, it converts the analog input into the equivalent digital output. Display device, it displays the data digital format. Digital recorder, it used to record the data in digital format. Today, IoT applications are on the rise and connecting objects are getting more and more important. There are several ways to connect objects such as Wi-Fi protocol. One of DAQ hardware is NodeMCU. NodeMCU is an open source platform based on ESP8266, which can connect objects and let data transfer using Wi-Fi protocol. In addition, by providing some of the most important features of microcontrollers such as GPIO, PWM, and ADC, it can solve many of the project's needs alone. The general features of the board are easy to use, programmability with Arduino IDE or IUA language, available as an access point of station, participate in event-driven API applications. As we get into the nitty-gritty of Wi-Fi signal strength, something to keep in mind is that there are several different ways that we can measure a Wi-Fi signal, which is milliwatts, decibel milliwatts, received signal strength indicator. RSSI, also known as the Received Signal Strength Indicator, is a measurement of how well your device can hear a signal from an access point or router. It's a value that is useful for determining if you have enough signal to get a good wireless connection. The ideal Wi-Fi signal strength is between 55 dBm and 70 dBm, depending on how close or how far away from the access point you happen to be.
After install the Arduino IDE software, we open the specific Wi-Fi file given. Then we go to File, choose Reference, then we go to Edison Boards Manager URL and key in the link given. Then we go to Tools, Boards, and choose Board Manager. And we go to Type, and search for ESP8266. Then we install the file given. After done install, we go to Tools again and go to Board and choose for ESP8266 board. Then we choose NodeMCU 1.0 ESP12E module. Then we go to verify the coding. After done compiling, we set up the hotspot name and the password. Then we connect our laptop to the NodeMCU for uploading the coding. Before uploading the coding, we go to Tools and go to Port and choose COM3. Then we can upload the coding. After done uploading, go to Theory Monitor. Then open our mobile phone hotspot to connect with the NodeMCU. After connected, you can see the RSSI unit is showing on screen. To make my task easy, I come up with two different measurements, which is 3 meter and 6 meter.
From this experiment, I have made two graphs to calculate mean, median, mode, and standard deviation. First one is for 3 meter distance. Like you guys can see, this graph is flow like a mountain is going up and down. First for mean, I get 64.5. For median, I get 63.5. For mode, I get 62 and 63. And last one, for standard deviation, I get 2.461. And for 6 meter graph, this graph is more going down and out. For mean, I get 72.8. For median, I get 72. And for mode, I get 70. And last one, for standard deviation, I get 3.120. Now you guys can see that system that I have developed can detect someone with distance between NodeMCU and mobile hotspot using RSSI function. When mobile hotspots located at different locations from NodeMCU, the value can be increased and decreased. As a conclusion, from this we can know this system can present human. That means this system can apply for safety purpose. For example, with this system, we can apply to certain company who want their private room not visited by other persons. They can give the device that have a hotspot to their workers or visitors and make a law to them that they have must to carry this device every single time they're in this company. So, if this visitor want to enter your private room, the NodeMCU will show the data of range between NodeMCU and hotspot that they carry. With this data, we can know that have someone here right now. This is how I complete the task that I have been given. Thank you.